Okay, good morning, everybody. This is going to be a lesson about composite functions, which will probably represent about a third of your homework on your homework 9 personal versions that you'll have to submit later this week and next week. Composite functions are what you get when you take two different functions and try to mash them together using an operation. So sometimes you're adding them, sometimes you're subtracting them, sometimes multiplying, dividing. But then the big one, the one that students find the toughest, is technically the one that we refer to as a composite function. And that's where you're taking like f of g or g of f, something like that. So we're going to start off easy. We're going to just do maybe some multiplication, things like that. So question 11 from homework 9A common version gives us two functions, f and g. They then ask us basically to multiply these two things together. This notation, f of x, g of x, when they're touching like that, that just means multiply. So we're multiplying f times g. Whenever you do something like that, you're going to need to use parentheses around your various functions. Because if I'm multiplying all of f times all of g, then you're going to need parentheses around it to make sure that you FOIL it out or multiply the right pieces times the right pieces. So essentially what we would be doing here to get f times g is FOILing out this long expression. That would be a pain in the butt, right? It's going to be a lot of steps, a ton of combining like terms, and it would take forever. So let's read the question more closely to make sure we're not doing extra work. The question asks us to identify the coefficient of x squared. So we actually don't have to multiply this all out. We're really only looking for the coefficient of one term. So if I were to FOIL this, we would have to FOIL our first term times our first times our second, and our first times our third. We'll notice that the first two arrows I drew are going to give us an x to the fourth and an x cubed. So those actually aren't even part of our x squared term, so I can kind of ignore them. Typically, we would need to multiply this all out, but since we're dealing with a very specific question, we can just ignore the other two multiplications. Then for FOILing purposes, we would multiply the second term by the first term, by the second term, by the third term. Well, that first arrow I just drew is going to give us an x cubed. The second arrow would give us an x squared, but the third arrow would give us an x. So we're going to erase two of those. And then finally, we would take the third term times the first, times the second, times the third. But two of those aren't going to give us an x squared. Only the first one is. So carefully erase those. So only three of the various pieces of our FOIL are actually going to give us an x squared term. So those are the only three I even care about right now. So tracing my arrows, my first multiplication was a negative 3x squared. My second one will give me a negative 3x squared, and my third one will give me a negative 3x squared. How convenient. When we combine all those like terms, we end up with negative 9x squared. Does that make sense? I know we kind of only halfway did this problem, but can I get a head nod or a shake if that makes sense to you? Okay, good. So the answer is the coefficient on our x squared term is just going to be negative 9. So that's what's written here to answer that question. Then they ask us questions about domain of our functions. This is not hard. The domain of polynomials is always negative infinity to infinity. We don't have to restrict our domain because we can plug any number we want to in for x. The only times we have to worry about restricting our domain are when we have fractions with x's in the bottom, because you can't let the bottom be 0, and square roots with x's inside of the roots, because you can't let a square root be negative, because then you get complex numbers. So we don't have roots, we don't have fractions. This is simply a polynomial. Our domain is always going to be negative infinity to infinity of f, of g, and of f times g. So in the next question, they give us a totally different f and a totally different g, and they ask us to combine these functions using division. So here's our f, here's our g, and they ask us to take g over f. So all we're going to do is set up a really big division problem. So we could write this as g, which is negative 4 over x plus 3, over f, which is 4 over x. This is my g over f. Now, we wouldn't leave our answer like this because this is really ugly. We've got fractions inside of fractions, so we're going to simplify this a little bit. This big, dark middle fraction symbol is, it just means division, right? It just means top divided by bottom. So I could rewrite this as negative 4 over x plus 3 divided by 4 over x. And division is just keep, change, flip. So we're going to turn this into a negative 4 over x plus 3 times x over 4. And our 4's can cancel. That's kind of convenient. So we end up with a negative 1x over x plus 3, which of course we wouldn't have to write the 1. We could just call this a negative x over x plus 3. So these are just a matter of, rewriting your functions together in the way they've told you to, and then simplifying it a little bit to get it into an appropriate form. But then they do ask you about the domain of this one. And I hinted at this a second ago. The only times we have to restrict our domain are when our functions contain fractions with x's in denominators or roots. And here we don't have roots, but we do have a lot of fractions. So I've got a ton of marks that I'm going to erase. Our composite function, when we put these two things together, looks like this. Now, we have a fraction with a denominator. So I'm going to circle some denominators. This is a denominator, the 4 over x. However, there are other denominators in this problem. The x plus 3 is a denominator, and the x is a denominator. So we actually have 3 different things to check for restricting our domain. So we cannot let x plus 3 be 0. We cannot let x be 0. And we cannot let 4 over x be 0. None of these 3 things could be equal to 0 because they're all in their own way, they're all a denominator. Well, solving these hopefully doesn't take too much brain power. On the last one, 4 over x can't be 0. If you multiply both sides by x, you end up with 4 can't be 0, which it isn't. It never is, so that's fine. We can just ignore this. Sometimes you end up with things that don't technically restrict your domain. So our domain must be restricted by these 2 pieces. X cannot be negative 3, x cannot be 0. So they've given you part of that up top. So one thing I do want to point out is that in our previous domain, we could already have looked at this and been able to say that x can't be 0 and x can't be negative 3. So we didn't actually change that. Whatever f and g are restricted by, a composite of f and g is also going to be restricted by that. Plus, the composite might have more restrictions, but it will at least have the restrictions that f and g each individually had. So watch out for those types of things when you're doing your own homework. Okay. Question 6 is very similar to question 7, except we're dealing this time with an f that has a fraction and a g that has a root. So when we go to talk about domain, there are quite a few things we need to look for. So in part A, they ask us for the domain of 1 over x plus 2. Well, since that's a fraction, we need to restrict it so that the denominator cannot be 0 So we end up with x can't be negative 2. For part B, we are looking at the domain of G, which is a root. And for a root, the interior of the root cannot be negative. So we restrict it to be greater than or equal to 0. And if we solve this, we end up with x is greater than or equal to negative 5. Part C then asks us to start taking composites. So in C, we're going to add f plus g. So that would be 1 over x plus 2 plus the square root of x plus 5. Now, if this could be simplified in a relatively straightforward way, we would do that. But you can't really simplify this. I mean, you could try to find a common denominator, but that would make it more complicated. So we're actually just going to leave our f plus g like this. We're not going to simplify it. So that's exactly what we've plugged in here on this line. Then they ask us for our domain. Well, we don't even have to do any work here because in order to find the domain of this, we have to restrict the bottom of a fraction to not be 0, and we have to restrict a root to be greater than or equal to 0. But we already did that work in parts A and B. So the domain that we list for part C is going to be a combination of the two domains that we already identified in A and B. So if you notice, we have x has to be greater than or equal to 5, and x cannot be equal to negative 2. So we've already done that work. We're basically just copying and pasting at this point. D asks us to multiply our two functions together. So f is 1 over x plus 2 times g is the square root of x plus 5. And this one can be simplified a little bit. It just becomes the square root of x plus 5 over x plus 2. And that's how we would write our response, just as a single fraction. Again, though, to find the domain of this function, this composite, we would restrict x plus 5 to be greater than or equal to 0, and we would restrict x plus 2 to not be equal to 0. We've already done that work. So this, again, is a copy and paste. Finally, for part E, they're asking us to divide f over g. So that's 1 over x plus 2 divided by the square root of x plus 5. So this one is going to be a little different. Let's actually do the domain first before we simplify, because we have two denominators now. So both of these denominators cannot be 0, but also our bottom denominator, x plus 5, is also inside a root, so this has to be greater than or equal to 0. So we've already done this work, and we've already done this work, but this is a new one that's coming at us that we haven't seen yet because we haven't had a function where our x plus 5 was in the denominator, but now it is. So instead of, I'm going to zoom in really closely on this one. Instead of treating this like x plus 5 has to be greater than or equal to 0, we're going to revise this. We just talked about, since it's in the denominator, it can't be equal to 0. So I'm going to take this off and then solve. So we subtract 5 from both sides, and we end up with x is greater than negative 5. So this part E will be a little different. It's not just a straight copy-paste job. Our function changed enough this time. We had a new denominator thrown in the mix that it actually is going to change our domain. Any questions about that one? All right. I'm just taking a look at this problem really quickly. Okay, this is basically just a domain problem again. This time we're given 3 starting functions, f, g, and h, and we're going to be compositing them in various ways. The first one just wants f divided by g. So f divided by g would be x plus 16 divided by x plus 31. To identify the domain here, we're going to need to restrict it so that our denominator is not equal to 0, which very quickly solves to be x cannot be negative 31. That's it for A. We restrict our domain. You can even write it like this. And then for part B, we are creating the function g times h, which is going to be ugly. X plus 31 times the quantity 4x minus the square root of 2x plus 2 plus 4. And it's a good thing they don't actually ask us to type this function in, because we'd have to FOIL this out and it would be a mess. Fortunately, we don't have to worry about that. All they ask us for is the domain. Well, do we have any fractions in this problem? No, we don't have to worry about denominators. Do we have any roots in this problem? Yeah, we've got one right here. So this is the only thing we have to restrict. 2x plus 2 has to be greater than or equal to 0. We're going to subtract 2 from both sides, and then we're going to divide both sides by 2. We end up with x is greater than or equal to negative 1. So hopefully you're seeing that these compositing problems are really not that new. This is just all the same domain stuff that you've been doing for weeks now. Question 22 is very similar to the very first problem we did today. They're asking us to composite f and g in a pretty unique way. We're going to take f of x plus, so let me get that written out, plus 5/6 times g of x. Again, make sure you've got your functions themselves in parentheses. The question they're asking us, though, isn't to simplify this whole thing and type it all out. They're asking us a very specific question about the coefficient of x squared. So if we were to simplify this, our x squared terms would include this one right here and 5/6 times this one right here. So our two x squared terms would be a negative 6x squared and a positive 55 over 6 x squared. And I said it was positive, so put a plus sign there. If I add these two things together, it's just a matter of finding a common denominator and then adding them together. We would end up with what? 19? 46, 56? Yeah, 19 over 6 x squared when we combine those two terms together. So they're just asking us for the coefficient of x squared. We put our 19 over 6 right there. So you can figure these out with only a very small amount of work, as long as you read the question carefully and kind of plan ahead. You don't have to calculate everything. Okay, so here's where we start actually plugging some numbers in to find some solutions to problems. They're giving us a few different functions, and they're going to have us plug actual numbers into some composites. So for part A, we want to find, we'll do this. For part A, we want to find f of negative 7 plus g of positive 7. So first, I'm going to rewrite f, but instead of x, I'm going to use negative 7 in that function. So we'll have 3 times negative 7 plus 5. That's my f of negative 7. Then we've got a plus sign, and we're going to throw in g. But instead of g as it's written, the square root of 10 minus y, we're going to put 7 in for y. So it'll be the square root of 10 minus 7. Is that clear so far? These both can be simplified. Not a ton, but the f, the red part, can be simplified to negative 21 plus 5, which will give us negative 16. And then the blue part simplifies to the square root of 3. 10 minus 7 is 3. And I can't really simplify that anymore because these are not like terms. One of them has a root, one of them doesn't. So we're just going to put our answer in like this. Negative 16 square root of 3. For part B, we're taking, I'll do these in different colors. We're taking g of 6 times h of 2. So think of this as a multiplication. G of 6 will be the square root of 10 minus 6. And h of 2 will be negative 4 over 2 plus 2. Just plugging in 2 to h. Now, we can simplify this. The square root of 10 minus 6 is the square root of 4. That'll simplify down to just 2. And then our fraction here becomes negative 4 over 4, which simplifies to negative 1. So this simplifies all the way down to negative 2, which is our answer for part B. For our third one, we've run out of space. Let's see. C is f of negative 5, which would be red, and h of 3. So when we plug into this, we'll have 3 times negative 5 plus 5. That comes from f. And from h, we'll get a negative 4 over 3 plus 2. So let's simplify this a little bit. We'll end up with negative 10 on top and negative 4/5 on bottom. We will keep change flip. So times negative 5 over 4. And we end up with positive 50 over 4, which simplifies down to 25 over 2. I entered my answer as a decimal for some reason. I think you can keep it as a fraction, your choice. Actually, I don't know if it's your choice. Web class might be super specific about that, so you might have to try entering your answer various ways. All right, everybody should listen up to this. Here's a formula for you. You have to know this. Make sure this is written in your notes somewhere. There's a formula that every economist knows, every accountant knows off the top of their heads, and it makes a whole lot of sense if you think about it logically. Profit is equal to revenue minus cost. Revenue is the amount of money that you get from your customers. So when you walk into Walmart and you pay $100 for a TV, Walmart's revenue is $100. But that's not their profit on that TV because they had to buy that TV for $75 from a supplier. So they take the $100 revenue that they got from you minus the $75 cost that they paid to the retailer, and their profit would be the $25 margin in between there. So profit equals revenue minus cost is a very logical concept, but you will use that in some word problems. So make sure you know that. And I'm not sure if that's something you guys already talked about this semester, but if you don't have it in your notes already, make sure you put it in there now. So in a word problem involving profit, revenue, and cost, they're often going to give you a couple pieces of information and expect you to find out the last missing piece of information. So in this example, this is question 20 from homework 9A common version. They give you the cost and the revenue. Took me a minute to find it. So they give you a problem where they tell you what the cost and the revenue are, and they want you to find the profit. So they say find the weekly profit function. So this is going to be a lot of me going back and forth with my screen because of the way this printed out. But let me just remind you that profit is equal to revenue minus cost. So this is going to basically be a composite function. We're going to subtract the revenue function minus the cost function, and that's how you get your profit. So our cost is equal to 40x plus 6. So that'll be our cost, 40x plus 6. That goes in as C. And our revenue was 400x minus 3x squared. So 400x minus 3x squared. So here we go. So this was our revenue. This was our cost. We've just written it as revenue minus cost. And then, of course, as with most responses, you're going to want to simplify your answer as much as possible. So I'll rewrite this with my leading coefficient. We'll go in descending order. So negative 3x squared plus 400x minus 40x minus 6. And then I'll combine my like terms. So you end up with 360x as your middle term. And that would be your answer. We're basically just compositing R and C to get our profit and then simplifying. Then they ask you a couple of snowball questions about where you actually have to plug things in. They say how much profit will be made by producing and selling 27 units of our item. So we're just going to take 27 and plug it in for X and use a calculator. You end up with 7,527. For part 2, they ask you for the maximum profit. So what does that sound like? This is a quadratic equation. It starts with an x squared. So the shape of this graph is a parabola. Parabolas have a max or a min at the point called the vertex, and we learned a vertex formula on Tuesday that you can use to find a maximum or a minimum. Well, we're looking for a max here. So if we want to find the max, what we're really looking for is the vertex. The x value of the vertex is located at negative b over 2a. You'll want to know that. Well, negative b over 2a would be negative 360 over 2 times negative 3. So that's going to simplify to, 60, positive 60. And you can use a calculator for that. So our x value of our vertex is 60. So that would be this, the number of hardware packs manufactured. The y value of our vertex is going to be what we get when we plug 60 into our equation. So negative 3 times 60 squared, etc. And this, again, just use a calculator. It looks like when I did that, I ended up with 10,794. I do want to caution you, though, one mistake I've seen students make in the past, not you guys, but other students I've taught this material to, is they go through the first step of getting this value and they think that that's the profit. It's not. It's the X value that gives you your maximum profit, but you have an additional step to find your profit. So make sure you're putting your answers in the correct blanks above. Okay, so question 4 asks us to composite our functions, but it does it in a visual way. This notation right here can be a little bit confusing. We're used to seeing something like f of x or g of x, but this notation, where the f and the g are together and the x is kind of by itself in parentheses afterward, that might look a little unfamiliar to you. But this means the same exact thing as f of x plus g of x. It's just notation. They mean the exact same thing. So if I want to take f plus g of 4, that's the same thing as f of 4 plus g of 4. So we can use our graph to figure that out. The graph of f is blue, so I'm going to label that so I don't forget. F of x is blue and g of x is purple. So f of 4 would be 1, 2, 3, 4, would be right here. So that y value is also 4. So f of 4 is equal to 4. And g of 4 would be negative 2. So we'd get 4 minus 2, which simplifies to 2. That's how you composite using a graph. Now we're taking g minus f, of negative 4. So that's g of negative 4 minus f of negative 4. G of negative 4 is 1, 2, 3, 4 is positive 2. But also f of negative 4 is positive 2. It's that same exact point. So here we would be subtracting 2 minus 2, which gives us 0. This one is a new type of composite we haven't seen yet. This is g of f of x. So basically, when we have g of x, we can plug whatever we want to in for x. We can plug in 1, we can plug in 10, we can plug in anything. What they're asking us to do is plug in whatever f of negative 1 is equal to. So first we have to figure out what f of negative 1 is. So we go to our graph, we find negative 1, and f of negative 1 is up here. Its value is positive 3. So inside the parentheses, we're going to replace f of negative 1 with positive 3. So then for our next step, we have to find g of positive 3. So we would count right 3, and that puts us down here at this point. And that value, the value of that point, the y value, would be negative 3. So these feel more like two steps, right? First we have to find f, and then we have to find g. So I think there's one more like that. Now they're asking us to find g of 3, which is a little strange to think about, but it won't be too bad. So first we're going to start by figuring out what g of 3 is. So I'll use blue this time. G is our purple graph, so we're going to be looking at the purple graph. Erase some of these other marks. G of 3 would be located right here, and that's negative 3. So I'm going to replace the g of 3 with a negative 3 on the inside. So now I'm looking for g of negative 3, which is going to take me to the other side of the graph. Negative 3 would be here at positive 1. So that's why we got 1 is our answer. Compositing is probably new, but did everybody follow along with that? That made sense? No questions? Question 13 is asking us to do a very similar process, but instead of a picture, we have a value chart or table, value table. So let's just dive into the first example. We're looking for f of g of 2. So we're going to start by figuring out what g of 2 is. Well, here's our graph for g, and when x is 2, g of 2 is equal to 1. So this becomes a 1, which means then we're looking for f of 1. So now we're going to be looking at f on our table of 1 gives us 1. So this is just 1. The next example asks us to find g of f of 2. So we need to start by figuring out what f of 2 is. So we're looking at f on our table, we're plugging in 2, and we're getting out a 4. So this becomes g of 4. So now let's go back to our table, but this time we're looking at g, and we're plugging in 4, so we're getting out a 2. So g of 4 gives us 2. And in our final example here, we have quite a few steps. We're taking f of g of f of 4. Whoa. So we're going to start on the very inside and find f of 4. So we're looking at f, we're plugging in 4. That'll give us a positive 3. So this will now be f of g of 3. So looking inside, we need to find g of 3. So that'll be g of 3 gives us 3. So this becomes f of 3. Finally, we're looking at f, we're plugging in 3. That spits out a 2. So our answer here will just be 2. So just another way of looking at basically the same problem we just did with a visual graph, you can do with a table, and it's kind of the same process. Here we go. Question 2 finally gets into what composite functions are all about. So on a problem like this, we actually have a bit of plugging to do before we actually get to the numerical part of the problem. So they want us to find f of g of -1. Before we do that, though, I'm just going to find f of g of x. So with these, you're actually going to start from the outside. If you're looking for an f of g of x, you're going to start with f. So I'm going to rewrite f, which was -2x plus 6. But anywhere there would have been an x inside of f, I'm going to leave a blank. I'm going to do that one more time. If I want to find f of anything, if I want to find f of you name it, we're going to be finding f of blank, and that would be equal to -2 times blank plus 6. And whatever I want to find f of, I'm just going to put it in that blank. Well, in this example, I want to find f of g of x. So we're going to put g of x in that blank. But g of x is something that we actually know what it looks like. So instead of just writing g of x here, we can put 4 minus x squared. So when we simplify this, we end up with -8 plus 2x squared plus 6, and that simplifies down to 2x squared minus 2. So we can find f of g of x and simplify it down to a nice, neat expression. Then that makes it really easy to answer the question, what is f of g of -1? All we have to do then, f of g of -1 would be 2 times -1 squared minus 2. We just plug -1 in to that composite function we've already made, and it's pretty easy to calculate. You end up with 2 minus 2, which is 0. That's how we get this. Then they flip it on us. For the second part of the question, they ask us to find g of f. So if I want to find g of f, first I'm going to start with the g on the outside. I'm going to rewrite my function g, but leave all of the x's blank. So g of blank equals 4 minus blank squared. Inside that blank, we're going to put whatever we're taking g of. So in this situation, we're taking g of f. So we're going to put f of x right in that blank. But we know what f of x is, so we can actually write it like this, -2x plus 6 squared. And in order to simplify this, we're actually looking at foiling that out, doing a lot of simplification, a lot of steps to get that simplified. So it might be easier to go ahead and plug in the 2 value so that our simplification doesn't take as long. So that would be -2 times 2 plus 6 squared. -4 plus 6 is going to give us a +2, so we end up with 4 minus 4, which is 0. So the reason I wanted to show the problem to you this way was because in some later problems, they might not give you values. My goodness. Okay, this is a lengthy problem, and they do give us values in this one. So let's look at A. They're giving us f of t, g of s, h of x, k of x, and they want us to find, first they want us to find h of 3. So we're going to go step by step here. I'm just going to rewrite h of 3 just to wrap my head around what they're asking me to find. Well, where in our problem do they tell us what h is? They tell us right here that h of x is equal to f of g of x. So I could rewrite this as f of g of 3. Okay, well now I need to figure out what f and g are, right? Well, when we're compositing two functions like this, we start on the outside. So we're going to start with f. So I'm going to rewrite what f is equal to, but instead of the variable, I'm going to leave a blank. So it would be 3 times blank minus 2. What am I going to put inside that blank? I'm going to put g of 3. If my pen would work, g of 3 goes right inside that blank. So we actually know what g is equal to as well, so we can calculate that. So this g of 3 value could become 2 times 3 plus 1, based on g here. And finally, we're looking at an expression that just has numbers in it. We've reduced all of our functions down to calculations, and we can actually solve this. So we get 3 times 7, which is 21, minus 2, 19. So our h of 3 was 19. We're going to have to do that again for part A, but this time they're asking us for k of 3. So k of 3 would start out as g of f of 3. And they want us to composite g and f. So if we go back and look at what g and f are, let's see. We're going to start on the outside with g. G was equal to 2x plus 1. So that would be 2 blank plus 1. And inside that blank, we're going to put f of 3, which would be 3 times 3, shoot, I already forgot it, minus 2. Simplify that down, you end up with 15. For the next problem, I'll probably only do one of these because they're so similar. I'll just do one of these examples. We'll start with w of 2. For w, we need to figure out where in the problem they tell us what w is. W is equal to k of p. So we would write this as k of p of 2. And we start with the k on the outside. K of x is equal to x squared. So we would write big set of parentheses squared. And inside that set of parentheses, we need to put p of 2, which is this here. It would be 2 minus 3 squared. So we've got squareds inside of squareds. There's a lot of compositing going on here. We'll end up simplifying this. 2 minus 3 is negative 1 squared, which will give us positive 1. Then that'll leave us with a positive 1 squared, which is just 1. So does that process make sense? Does anybody have any questions about what we've done in these problems? I'm going to skip the next little piece of this because it's very similar to what we just did. You even end up with the same answer. And move on to the next one. For question 24 on the common version of the homework, we are compositing functions, but then we're not given a value to put in there. So what we do is we start with the outside and we work our way in. We want to take f of g of x. So we start with f and we rewrite it, leaving blanks anywhere we would normally have a variable. So negative 7x squared plus 6 becomes negative 7 blank squared plus 6. Inside that blank, we're going to put g of x. But we actually know what g of x is equal to. So we're going to write in what g of x is inside that blank. It would be 4 minus 4x. And then we're looking at something that can be simplified. I don't know how picky web class is about how you simplify these things. So you can try to put your answer in like this, and that's what I've typed. Um, I don't know if it says okay, does that mean that like you typed it in right? I don't know what that means. So try putting your answer in like this. If it doesn't accept it, you might have to FOIL this out and then distribute the -7 and simplify it. I'm not sure. So don't give yourself more work than you have to. But if they require you to simplify it, then of course you'll need to do that. For the next problem, we want to take g of f, so it's actually the reverse. Here we start with g, and which was 4 minus 4 times x, but instead of an x, we'll leave a blank. And inside that blank, we need to put f of x, which we know is equal to -7x squared plus 6. Now this one's pretty easy to simplify, so you might want to go ahead and simplify this just by multiplying this through and combining like terms. But does that process resonate? You follow in like leaving a blank, plugging in what you need to plug in? That is basically a wrap.